Hey everybody. We're going to be moving on to the next unit, and the new unit is actually called Scale Factors and Similarities. Now, some of you may have worked with some of this stuff. Some of this might just be a refresher. Others, you may not have worked with this as much or as in depth. Either way, it doesn't really matter. We're going to be going through everything all over again, okay? So just bear with me for the parts that you understand or the parts you already know, and for what you haven't already heard of, then we'll dig into that. So we're just going to start off with a few definitions first to kind of discuss what we are really looking at in this particular lesson, which is 4.1, scale diagrams. Now, scale diagrams is it's something that you work with, maybe not on a daily basis, but you definitely have worked with it. For example, in order to create a map of the world, you had to create a scaled diagram. So what you have in your hand is obviously not the real size of the world. It's a scaled diagram of what the real size actually is. So starting off with the very first definition, this is called a scale. And now a scale is a comparison between the actual size of an object and the size of its diagram. It can be expressed in many different ways: a ratio, a fraction, a percent, in words, or in a diagram. And so basically what it says is a scale of 1 to 32 signifies that 1 centimeter on the diagram represents 32 centimeters on the actual object. Now, actual is also going to be used. We're also going to use the another word like the real object. The real object is the one that we originally started with. Okay. The next definition is going to be called a scale diagram. Sorry, that's D-I-A there. You can't really see it very well, but there's an A in between there. There we go. A scale diagram. And it's a drawing that is similar to the actual figure or object, not identical, similar. Very important you know the difference of that word. It may be smaller or larger than the actual object, but it has the same proportion. So what that means is if you made one object 3 times bigger, every side of that object is 3 times bigger. And the very last word is called a proportion. Now, a proportion is a relationship that shows 2 ratios are equal, and it can be written in different formats. So, for example, if you were to say 1 girl for 4 students is equal to the ratio of 5 girls for 20 students, you can write it in fraction format, which is right here, or you can write it in a ratio format, which is right here. Moving along. Okay, so going off an example 1 here, the scale diagram of a wagon uses a scale of 1 to 14. What is the actual length of the wagon? So basically what that means is we are looking at diagram here, okay? And so what they're saying is that obviously this wagon was created by somebody, and then somebody else decided they were going to go and draw this wagon here. Okay, and so the length of this wagon right now is currently 5.5 centimeters in this diagram. So we want to know, what did the original wagon, what was it measuring at? And so by looking at that, we have 2 methods that we're going to do. We're going to use either the scale or use a proportion. So using a scale, it means that a scale of 1 to 14, it signifies that the actual dimensions of the wagon are 14 times bigger than those of the diagram. So it means that it is an enlargement, is what we call, like the real wagon is enlarged compared to the drawing. Now, if you multiply the length of the wagon in the diagram by 14, you would have the following math. So you do 5.5 times 14, and that will give you a total of 77 centimeters. And so the actual length of the wagon is 77 centimeters. And so we would write that down with units because we are trying to figure out the length of something. Now, going off onto the next method, it's called using a proportion. And using a proportion, this right here, the scale equals diagram measurement divided by actual measurement. And keeping in mind, the actual means the real object. This is something right here that I would write down on my cheat sheet if I were you guys for a test or an exam. Okay, so that right there is my equation to use. And so if I fill this out, what I know is that the scale is 1/14 right here. Okay? And I know that my diagram, my picture up top there, it has 5.5. But what I'm trying to figure out is the length of the actual measurement right here. So now this, what it becomes is a cross multiplication. So you times those two numbers. And then what you do is you divide by that. Now that's just a little bit of a trick that I have. So basically you look on the side with the variable, you look at the number, and then you cross multiply it, and then you divide by the other number. So it looks like 5.5 times 14 divided by 1, and that equals x. And so 77 centimeters equals x, which means that your actual length of your wagon is 77 centimeters. That works with that. Now, moving on with our lesson. We have another type of example here. So this example is going to get us to determine what the scale factor actually is. It's going to be the opposite of what we just did. We knew the scale factor before, and so we tried to figure out a length of something. Now we know the length of both diagram and actual measurement. Therefore, we want to try to find the scale factor. So here what we have is a diameter of a quarter is equal to 23.88 millimeters. Very careful on that. It's millimeters. We want to calculate the scale factor used to draw the quarter, and we want to round our our answer to the nearest tenth. So what this means is that we had the original quarter in our hand, like the physical quarter, and then somebody decided to go and make a drawing of this. So if you look at this right here, I know it's kind of easy for you guys, but this is telling me that it is a length, the diameter is a length of 26 millimeters right here. So that's how we get 26 millimeters, okay? And so the diameter of the drawing of the quarter measures 26 millimeters. Now, if we set up a proportion for the scale and the measurements, so setting up that proportion, quick little reminder that that means that we are working with equal proportions. So the scale in this case would be equal to, now the diagram measurement is 26, and the actual quarter is 23.88. Okay. Now, because we're dividing measurement by measurement, and they have the same units, your scale factor or your scale will never have any units. This is one of the very extremely few exceptions that we have in math that you will actually get marked points off if you write units down for this. So there's no millimeters, there's nothing written down for a scale, okay? And so this one right here, if you write down scale or scale factor, it's either or really is perfectly acceptable. The total comes to 1.1. So just a quick little reminder here for you guys. If the scale factor is greater than or larger than 1, it is an enlargement. So that means that it's made larger than what you originally had. Okay. Now, if the scale factor is the opposite, so is less than 1, it is considered a reduction. Those are two things that I would write down on a cheat sheet if I were you guys as well, just to make absolutely sure that you remind yourself, especially using the words enlargement and reduction. Those words will come a lot in handy a lot more often as we continue on with this lesson, this unit, but just so you guys are aware, okay? So this means that the scale factor is approximately 1/1 because that was obviously rounded. And this means that the quarter in the diagram, is 1.1 times as large as the actual quarter. So which means that what we drew out up top here, this drawing, this diagram, that is considered to be an enlargement. All right, moving along here. Now the next thing that we get into for this lesson here